this series of introduction to programming in C++, today's topic is parameter passing in functions. So in previous lectures you have seen that we are we have started with our modular approach to programming, which is kind of functions, and now we are getting more idea about functions. So in functions, in what and how many ways your parameters can be passed, that is the agenda for today's lecture. So in order to implement a function call, as I have already told you, there is going to be a calling module or calling function which calls a function, and the function which is being called is known as called function. So whenever a function is being called, what actually happens, or more specifically we can say how a function call is being actually implemented. So in order to understand that, let us take a look at the figure given on the screen. So let's say, for example, I have called function which is my function by passing two values, which is val1 and val2. These are the two parameters which are being passed to the function named as myfunc. Now what happens when this function is being called, or let's say you write a statement myfunc is val1 comma val2 in the main. So from main, the control is being transferred to the definition of myfunc. So let's say definition of myfunc is given at the end. So myfunc will start working, which is void myfunc x comma y. So val1 and val2, basically you can say they are your actual parameters, and a copy of those parameters will be created in which the value of val1 and val2 will be copied, which is 10 and 12, and though that copy of these two variable is named as x and y respectively. So there is a copy of val1 which is x, there is a copy of val2 which is y, and having value 10 and 12 respectively. Now myfunc is actually working on these two variables x and y. It says x is equals to 40 and it says y is equals to 50. So that means essentially your function is changing the value of x and y both. So that's perfectly fine. Whatever processing your function wants to do, or specific functionality which is required, that your function module can perform. And after the closing curly brackets of myfunc, the control is being transferred to the next statement written just after that function call in the main statement. So that is how a function call is being implemented. Now coming to, in order to call a function, we simply needs to pass the required parameter along with the function name, and if the function is going to return any value, that value you can store in the return value. But whenever I am coming to the parameter passing, the along with the control, whatever your calling function is going to give to your callee or called function is known as your parameters. So let us try to revise this terminology of parameters very clearly in order to go ahead. So there can be two types of parameters as the terminology permits. One is formal parameter, another one is actual parameter. So formal parameter is a variable and its type as they appear in the prototype of the function or method, while the actual parameter is the variable or the expression corresponding to a formal parameter that appears in the function or method call in the calling environment. So for example, if you remember the previous scenario, myfunc val1 and val2. So this val1 and val2 are actually the parameters which are appearing in the environment of calling function. So that is what you called actual parameter, and the values of these actual parameter will be copied into x and y, those x and y are known as formal parameters. So basically those variables as they appear in the prototype of function or method. So here is a clear differentiation between actual parameter and formal parameter. Now coming to the focus of the lecture, which says what are the important methods of parameter passing, or what are the ways through which you can pass parameters into your function. So basically there can be many, but here we are going to cover two, which one is call by value, another one is call by reference. So whenever I am talking about the term reference, that means I am referring to the reference of the variable, which is either in the form of addresses or in the form of pointers. So the term reference itself is an indication of pointers and addresses. So basically two methods, one is call by value, another one is call by reference. So let us try to understand these kind of methods one by one. So call by value. So call by value says whenever you are going to make any change to formal parameter, that change is not going transmitted back to the caller. So that means, for example, we have taken value of x in our previous example. If you remember, the value of x was given 40 and the value of y was given 50. Now after transferring the control back to the main function, is this x and y being passed somehow to the main function, is given back to the main function somehow? Actually no. What is being given from a called function to a calling function? That means whatever your my function is going to give to main is either a return value and kind of control, we can say control. Yes, it is going to be transferred back to the calling function main or whatever the calling function is, and if there exists any return value, that return value also goes back. So val1 and val2, when any copy of this val1 and val2 is being created, whatever changes are happening on that copy of the variables, those changes are actually not being reflected on the original value of val1 and val2. So essentially what I can say is any modification to the formal parameter variable inside the called function or inside that particular method affect only that copy, affect only that separate storage location. It is not, the changes are not reflected in the actual parameter in the calling environment. Now let us try to understand how it is happening. So for example, I have taken that function again with a kind of bit of name change. So I am having val1 and val2. So val1 and val2 are given two values, 10 and 12 respectively, and whenever this call is being executed, that is kind of now that call is transferring the control to the function definition. Along with the control, there is being created a copy of val1 and val2, which is 10 and 12. Now there are two formal parameters, num1 and num2. So num1 is having value 10, num2 is having value 12. So what I am trying to say here is the value of your actual parameter is being copied into formal parameters. Now if I am going to say my num1 is 40 and my num2 is 50, what will happen? Num1 has become 40, num2 has become 50. That's perfectly fine. But is it going to reflect to the above val1 and val2? No. And after closing statement of your this function, only the control is the thing which is being transferred to the main function, and there is no change in the value of val1 and val2 because the value which is being changed is of num1 and num2, which are copies of val1 and val2. The original value of val1 and val2 is actually intact. So I can say it as the value being passed to the function is locally stored by the function parameter in a different memory location, which is kind of an stacked memory location. So if your program, if your module, or if your function is going to change the value of that parameter, it is going to be changed for that current memory location, or it is going to be changed for the current function only. It will not change the value of variable inside the calling method, such as main or any other function which is calling the another function. So value of val1 and val2 will remain intact. Instead, the value which is being changed is of that copy which is in the name of num1 and num2, or which is in the name of x and y. That is, that copy is going to be changed or being affected by the statements written inside the function, not the original value of your actual parameters val1 and val2. So here you can see one more example. Here is a function prototype. This is a code snippet which is needed to be written inside the main thing, obviously. So here is a function prototype, or we can say function declaration, which says void change integer data. So basically the return value is void, and the we can say what the parameter, only one single parameter which is in the name of data, and it's of type integer. Now inside main I am saying, let's say data is equals to 3, and that 3 is being passed to the change. Now what will happen? Now even if the names are same for your actual parameter and for your formal parameter, you can notice the call change data inside main, and you can notice the definition which is void change integer data. But these data inside the function call and inside the function definition are two different variables. So one is the variable data which is being handled by main, another one is the variable which is data is being handled by your function change. So what will happen? The value of the data main function will be copied into the data of change function, which is your formal parameter. So even if the name of actual parameter and formal parameters are same, there are going to be two different copies. And now within the kind of function, if I say data is equals to 5, so which data is equals to 5? This is the data which is being created as a copy when your change function is being called. This is not the original data or the data which is declared as 3 inside the main function. This is the copy of the data. So that copy of the data is being kind of, I can say, being given value as 5, and your function ends. So fine. So when your functions ends, the control, as there is no return type, there is only control which is being transferred to the main function back. So it says cout value of data. Now which data it is being referring to here inside the main? It is referring to its original data. Its value is still 3, it has not been changed. The value which is being changed is of the data which is inside that change function. So as output, value of data is 3. This is what you are going to get, and then your functions end. So this is what actually an example of the way of parameter passing, which is basically known as call by value. Now coming to the next kind of we can say method, which is opposite to this call by value and better known as call by reference. Now here we have seen that we are creating a copy of the parameters, and the actual values are not being transferred. These are the two I can say punch lines for your call by value procedures. Coming to call by reference, in call by reference the original value of your actual parameter will be modified. Why it is being modified? because we are not creating any other, we can say any other copy variable. Instead we are passing references, instead we are passing the address. So basically what is happening here, address of the value is passed in the function. So actual and formal arguments, actual and formal parameters share the same address space. That means the actual parameter is pointing towards the pointing towards one location of memory, and because that address is being passed, the formal parameter is also referring to that particular memory location. It is not referring to any other copy of the, kind of, we can say any other copy of the variable or the parameter. So whatever values or whatever modification to the values you are going to do inside the function will be reflected onto that particular memory space. Hence we can say it is reflected inside as well as outside the function too. Now let us try to understand what is happening here with the help of a code snippet. So here we have void swap integer x and integer y. Now please notice that these are not normal integer variables, these are pointer variables, and in order to understand what a pointer variable is, please refer to the previous lecture. So integer asterisk x, that means a clear indication that x is a pointer variable. Integer x asterisk y, that means another clear indication that y is also a pointer variable. Now try to think, if there is a variable which is a pointer variable, what it is going to store? A pointer variable is always there is to store an address. Yeah, fine. So now I have taken one kind of temporary variable, we can say, which is swap or whatever name you want to have. So within the swap I am putting the value which is being pointed by x or value at x, then value at x is equals to value at y, value at y is equals to swap. So with the help of this pointer variables or with the help of this operator which is value at x, so value at x will be something given given to swap, then value at y whatever it is will be given to value at x, and then whatever value is stored at swap will be given to value at y. So here is the kind of, I can say, definition of the function swap. Now how this function swap is being used in the program, let's see. So now I am having, let's say, x is equals to 500 and y is equals to 100, and while calling the swap function, please remember that swap function was having variables of type integer. I have already told you in the starting of the functions that there has to be a clear match between the formal parameters and the actual parameters. That means in terms of their types and in terms of their number and in terms of their order too. Or whenever there is any function which is having two pointer variables, so while calling that function we will be we can say take two variables or two address variables or two addresses, because pointer is a variable which is going to store address. So if there are asterisk x and asterisk y, in order to catch here from calling function we will be throwing ampersand x and ampersand y. So ampersand x will be stored inside the pointer variable x, ampersand y, which is the address of y, will be stored inside the value of y. So now what will happen? X is equals to, value of x is 500, value of y is 100, and there will be some hexadecimal format address. These addresses are being passed to the swap function. Now here what will happen? The swap function is being called. So the moment swap function is being called, those addresses will be stored here. And now please look at the code and try to understand what is happening. So there is a normal variable swap. Now that swap is going to hold whatever value is at x. So asterisk means value at x. So at the address of x, whatever value is, that value is 500, that is being stored in swap. Now please notice no extra copy of that actual parameter is being created. It's just the kind of game of references. So here asterisk x is equals to asterisk y. So instead of 500, 100 is being stored onto that particular location which is being pointed by x, and asterisk y is equals to swap. That means that value 500 which was earlier stored in swap is given to that value, or is given to that place which is being pointed by pointer y. So what is actually happening? The whole kind of swapping is happening with the help of pointers. No extra copy of your actual parameters is being created. That means the whole game is played around the actual whole game is being played around the actual value of those parameters. So now after calling this swap, if you are going to we can say print the value of x and y in order to look at the results, so value of x and y you will find as swapped. Now instead of absence of these addresses and pointers, it is going to be a simple call by value. So you will not find that swap being reflected inside the main function. The swap is being reflected inside the main function just because of the presence of pointers and addresses, because of which there is no another copy being created. The thing which is the implementation, the execution which is being happening is onto that particular one copy of your actual parameters. So that's what the idea behind call by reference and call by value is. So in order to see what is the difference between call by value and call by reference in a nutshell, let's try to summarize it. I can say a copy of value is passed to the function in call by value, while in call by reference an address of value is passed to the function, no copy is being created. As the next point, I can say changes made inside the function are not reflected outside that particular function onto any other function, whether it is a your calling function or any other function which is outside. The changes made reflected inside the called function will not be reflected to the outside world, while the changes made inside the function in case of the call by reference, it is these functions are reflected outside the function too. Now actual and formal parameters in case of call by value will be created in different memory locations, and they are we can say replica, a copy of actual parameters being created, and that is given to the formal parameters. While in case of call by reference, it is not going to hold. The actual and formal arguments will be created in the same memory location. So if you can see the depth of call by reference, so earlier I have told you that there is going to be only one single return value which you can return from your called function to the calling function along with the control back. But if you can see this call by reference minutely, you will come to know that this call by reference is a way through which we can return multiple values. So in the swap example, we have modified the value of x and y, and that modified value is being reflected to the program. So essentially what are we doing? We are returning more values to the main function or to the calling function. But in C++, by default arguments are passed by value, not by reference, and the changes made in the called function will not be reflected in the passed variables, and the changes made into that copy or into that colon will be made by the called function, not in the original thing. So, if we wish to modify the original copy directly, we need to use call by reference. So, here in this lecture we have gone through fundamentals of call by value and call by reference. So, I hope you have got the concept clearly, and here is a list of references which can be which is actually being used in preparing this lecture. Thank you for a patient hearing.